this is Plug, the Portland Linux Unix group. So there's some new faces. I don't think I've seen you before. Or you?
My name is Austin.
Awesome.
My name's Kai.
Okay. And where have you heard about it?
I used to go to these like about 5 years ago.
Awesome.
I just moved back here. So.
Perfect.
I ran the Oregon State University Linux users group last year.
Okay. And you have not been here before?
I have not been here before.
Okay.
But I know
Somebody else
that-
from that same
That
group.
would be Robert. Who
Could
was,
be. I don't
3
remember.
years before.
Awesome.
That's how I
Okay.
heard about this.
Okay, so this is Plug. You notice we got a sign up here. There's 3 things. Before the speaker, I'm almost always in a gigantic panic for speakers. I got Jason to agree to do this like, I don't know, 10 days ago or something.
Yeah.
However, somehow I've like got a string of people out into the future. So we have a guy who's gonna talk about Plan 9 in December, which I'd never seen before. Turns out it's like living in St. Helens or somewhere. And he's on the damn foundation. He's like the treasurer of the Plan 9 Foundation.
That's next month?
Yeah,
Cool.
December or whatever the hell first Thursday is. I've also talked to a couple other people, somebody from EFF and a guy who, Steve Heminger, know him? You know, IP Route 2,
Mm-hmm.
he maintains that.
Okay.
So he's been around a long time. Both of them I talked to at the recent EFF speakeasy thing. I don't know if anybody's a member of EFF and saw the little announcement, but I was there and I was jawboning everybody substantially to try to get them to speak. And they both said, oh yeah, I could do that, but call me in January. Speaking of January, it turns out first Thursday in January is January 1st. So I'm thinking we're just gonna scotch January meeting, so we'll just go straight to February like January didn't even exist. But, so that gets us a few months down the road if these other people follow through. However, there are other months after that. And so if you know nerd people who want to like talk about stuff they're working on, this is a dynamite place to do it. So ask your friends, basically. Okay, so that's speakers. We have a monthly clinic where helper people come and helpy people come, in theory, and we help them. And we change the problems that they came with into different problems. We've actually had a guy come the last couple times and we helped him, I think. He's not so sure. But it's the 3rd Sunday of the month. It's at the EcoTrust building. Willamette University has a office here. It's got a name and I don't remember what, Graduate Center for something or other. And they got some nice classrooms. It's on the 2nd floor, so that's where it is. You can also look on Calligator if you know what Calligator is. There will be an announcement. There might already be an announcement for that on Calligator. And that'll give you the details. When you got here, there was a little sign on the outside door with a phone number that actually goes to my phone over here. And in theory, if you get to the door and it doesn't open, you can text me at that number and I will come open the door for you.
If you care, that's where if you want to be on the screen. So that's where it is.
Okay.
Yeah.
So if you want to like participate in helping people, you should consider coming to the clinic for funsies. And again, that's a monthly thing, 1 to 5 p.m. on the 3rd Sunday. After this, we've been going to Patty's, which is down at First and Yamhill, I think, and drinking various beverages and eating various foods. So if anybody wants to do that, we can probably give people rides if they need them, or you can walk if you want, or ride your bicycle.
Good.
So that's it, and I'm going to let Jason take it away.
Nice, thanks Russell. It's nice to see everyone. Thanks for coming out on such a lovely, beautiful day. Oh my gosh. Yeah, thanks for having me. I don't think I've been to a Linux users group here for the better part of 20 years.
Yeah.
I remember once I lived in Hillsborough for a year and I tried coming out to one of the traffic was so bad on 26 that it took me like 90 minutes to go like 4 miles, and I turned around and went home. So anyway, that was a long time ago. I haven't really run through this. It was kind of last minute, so we'll see how it goes. I'm going to try to keep it to about 30 minutes. We'll see. We can have a bunch of Q&A if people are interested in that after. I grew up in the area. I've been using Linux since I installed Slackware, like in the 90s, and you know, that was an experience. It's a lot easier these days, isn't it?
Well, kind of.
Yeah. Yeah,
Depends on hardware.
Depends on your hardware. There was a group here, there is a group here called dork.pdx. It's people doing strange things with electricity. I think that might be how I met Russell.
Yep. I know.
And I ran that for about a decade. It's still going. They meet at Control H if people are interested in like the kind of the intersection of electronics and art and multimedia. I ride my bike here. I ride my bike sometimes, and I really love horror movies. You'll see some horror movie references in this ridiculous talk because I'm into it. And there's an organization called Futel that Russell's familiar with, and some of you might know. It's a nonprofit that installs payphones around Portland and other areas. And we maintain I would say smallish, but a growing network of it's the fastest growing free payphone organization probably in the country. And if anybody knows what this is, you know, I'd like to be doing more with my call sign and using my ham radio license more. There's actually like a Linux net if there are hams.
I've heard of that.
Yeah, it's like people talking about Linux on the ham radio. It's pretty intense. Anyway, I just lurk. Yeah, I'm a software engineer as my profession. I work for a company called Splunk, and I contribute to this project we'll be talking about tonight called OpenTelemetry. And this talk is just me. My employer has nothing to do with it. Cool. And that's my primary, just like website, a couple of handles on GitHub. So yeah, what is OpenTelemetry? If you're here, maybe you've heard of it. Has anybody heard of this before? A couple of people, like 3. And have you used it or tinkered with it at all? A little bit? Cool. Well, hopefully in the next 30 minutes you'll leave with a little more knowledge about like what this is and what it's good for. So yeah, kind of the short, distilling this whole talk down is trying to answer this question: is like what can I do to see what my software and the systems that they're running on, what are they doing and how are they performing and behaving? That's really the whole. If I just distill it down, I don't think you'll see these words on the website necessarily, but that's kind of my summary of like what this project is about. I think everyone remembers these days where you would have, you know, a box sitting under somebody's desk or back in the back, and you would SSH into it, and you would like go find, like, we were all probably webmasters at some point. I mean, if you're my age, maybe you were, maybe not, some younger folks, but yeah, you would go find the Apache log, and maybe you'd throw some grep at it to see what the problems were. You'd tail it like in another window if you had the luxury of having a second CRT, and then you would like, you know, use some common command line tools, and those are great, and we got tons of mileage out of those, but they just don't scale. You know, here in the future when we have fleets of machines running in the cloud, it's really hard to apply these same kinds of tools at scale. Welcome, hi. And some people might have run this ridiculous monitoring tool. It was also called NetSaint for a while. You know, we ran these and monitored servers with them. Yeah, so, you know, what's the goal? Like, so I want to be able to answer some of these questions, right? If I'm operating microservices at scale in the cloud, it's like which services are talking to which other services? Because that's not always obvious, especially in larger organizations. And how long does it take when that one makes a request over here? Like, you know, it's important to know. Is it slow? Is it fast? Is it different than it was last week? And then, you know, if you have a cache, you might be wondering how fast that cache is. Has it gotten slower over time? You know, answering like business level questions or even security level questions, like how many logins were attempted this week, maybe how many of those failed. Another question that's commonly asked is like, what was the thing doing right before it crashed? You know, you want to have this context of like what was happening before the thing went down. And like, You were mentioning something about allocated memory. Is that the same thing as memory used? Like, I don't know. Are we talking the same language? Like, so all of these are kinds of concerns that the OpenTelemetry project hopes to shed some light on. Some jargon. If I live in this world for my day job, so I might say these things, but if I say K8s or Kates, that just is like a shortening of Kubernetes. You take out the middle 8 letters because it's a lot of letters. Same thing with observability. We take out the middle 11, we crunch it down to Ollie, and then OpenTelemetry is abbreviated OTel. So if I use those, there's your jargon, you know what I'm saying. So I have to do a little bit of for those who've never heard of the project, a little bit of background. There were 2 standards that were starting to emerge around tracing. There was one called OpenCensus and one called OpenTracing, and they realized, hey, we're basically doing the same thing. Like, we have such similar goals, let's just combine forces. And so they did, and the result of that was OpenTelemetry, and I think it was founded about 6 years ago, maybe approaching 7 years ago is when the project was founded. And we'll touch on a little bit of the kind of the origin story of it. So, Linux people in the room, you've probably heard of the Linux Foundation. It's a pretty massive organization. Some stats, so this is like I think right off the main front page of the website. They have over 900 open source projects. There's 3 million developers. It's like a big org. So within the Linux Foundation, there are several other child orgs. One of them, here's a bunch of other child orgs and projects. They kind of mix projects and orgs on this page, but whatever. The one here in the upper left-hand corner is the Cloud Native Computing Foundation, or we just call it the CNCF. And it's also a pretty sizable organization. It's got a lot of backing from a lot of big companies with a lot of money. And that is the place where OpenTelemetry is hosted. So they have 212 projects. They kind of classify, the CNCF classifies their projects as like kind of new, I forget the term for it, like fledgling or something. And then there's incubating projects and there's graduated projects. And graduation means that the project has fulfilled all the characteristics and demonstrated that it's like a viable, robust, interested project that has longevity and can be secure and run in production and all these good things. And so OpenTelemetry is currently an incubating project. We've been close to graduating. We're getting closer every year, but there's only a few that I know of that are graduated. I think Kubernetes is graduated, and I think Prometheus is graduated. Right, so yeah, OpenTelemetry, we're still in the boring parts here. I just clicked that button on the CNCF page, and this is like what comes up next. I don't think we use this thing at all, but it's still there. And then we definitely don't use Gitter anymore. Has anybody heard of Gitter? Yeah. Yeah, it's like a dedicated like chat system for GitHub repos. We don't use that thing. We're pretty active on Slack. Definitely GitHub's where all the action is, and yeah, there's some dev stats. So CNCF has this dev stats that keeps very intricate telemetry about their own developer contributions and project velocity and stuff. So it's pretty cool to check out. Yeah, so it's a very active community. I think we've got over 1,000 developers any given year, and there's 91. As I counted the other day, there's 91 GitHub repos in the OpenTelemetry org. And like I said, hundreds of companies with thousands of contributors. We're still in the boring part, but it's like 8 of 8. It might still be boring after this, but I'm gonna try. Like any sizable open source project, there's a governance committee, and there are guidelines that are all written down with words, and you can go read them. That talks about the responsibilities of these various committees. There are special interest groups for every language, like programming language special interest groups, but there's also one that's like a special interest group for the semantic conventions, and there's a user group, a special interest group for end users, like adoption and usability concerns. There's one that focuses on the website and the blog, like our docs team, and I contribute right now. I've contributed in a bunch over the years, but the ones that I mainly contribute to now are Java, and I'm a maintainer of the Android repository, the Android agent repository. Cool, and we go to conferences and we like do stuff. Next week is KubeCon North America, so we're gonna have a pretty strong presence there. Okay, so what? Like, who cares about all this stuff? Blah blah's like is not very technical. It's a boring talk so far. So like, what actually is this? You're just talking about any random open source project, right? It's a bunch of people aligned to achieve this goal of making software observable. There is a formal specification that describes the API and SDKs that an implementation must have. There's also a set of protobufs and a description of OTLP, the OpenTelemetry protocol. So how two things will communicate data between each other. A ton of implementations, like basically one for all the popular and some unpopular programming languages. And something called the collector, which we'll dive into more, and lots of other tooling. So there's a lot of software in this project, as one might imagine. Yeah, again, like, come on, Jason, like you're just saying all these words. Okay, what are we doing here? What are we actually trying to see? Okay, so if software observability isn't your world and you're kind of new to this, we're gonna cover the basics. So probably everyone in the room has touched a log record or generated a log at some point. That's kind of the first, most basic signal that OpenTelemetry considers. This is not comprehensive. There are a couple of others that are being birthed, but really the core concepts revolve around these three signals: logs, traces, and metrics. So logs, I think I just pulled that one off of one of my websites, and it looks like this. In OTel lingo, and this is summarized, it's not comprehensive, but the main things we care about when we're talking about a log is a timestamp, like when something happened. A body, which is like vague, right? It can contain kind of arbitrary structured or unstructured text. Usually there's a severity level. Is it important? Is it really debug or informative? And then optionally trace context. We haven't described what trace is yet, but you can imagine some additional context that could link a log record to a trace or part of a trace. And then there's just a bunch of key value things that are called attributes. Attributes is a core thing in OpenTelemetry. So strongly typed key value pairs. And then there's other stuff called instrumentation scope and resource that describe the thing that made the data point. So resource is like, the resource is like, usually it's like process level stuff. It's like host and process and version and like some other stuff like that. So all of that kind of lumped together makes a log. Oh no, this redneck zombie came along and he's like, oh, what's a log good for? Like, why would you want one of them? Okay, so you want it because it's easily understood. I think you can look at it and instantly just go, yeah, it's just like this it's just like just a human readable blob oftentimes. We've all seen it. I mentioned that it can carry structured or unstructured data. It's a pretty broad like carrier for other stuff. You can go back later, not having designed something to be searchable, you can go back later and search through your logs using grep and other tools. If you need an audit trail, you can stuff a bunch of logs into a tape drive or an S3 or whatever people do with audit logs these days. There's lots and lots of existing tools out there for munging and handling logs, and they're easily stored and they compress well. Okay, traces. Also known as distributed trace. Usually when someone's talking about a trace, it doesn't necessarily have to be distributed between services, but it often is. And so kind of the abstract concept is that it's a tree of timed invocations among a collection of services, which could be one, but usually several. And it shows how a request or an operation kind of flows through a network or a graph of microservices often. And the smaller unit of a trace is something called a span. Oh, and this totally can be interactive, like you all can just like ask questions or tell me I missed something, or if it's unclear, just like yell at me. So this is a screenshot from a tool called Jaeger that is also, I think, a CNCF project. It's an open source tool that you can feed tracing data into and view this thing that's called a trace waterfall. It's usually called that because there's a root operation, and then you see all the children, just kind of like a tree. Turn your head and you can see a tree structure here. And each one has a duration. You can say that there's some stuff kind of happening in parallel here, some stuff happening in parallel here, taking different times. Anyway, so you can make a trace waterfall out of the spans. What the heck is a span? Like we saw on that previous screen, start and end time, so you have a duration. There's something called the context, in this case a trace context, that has an identifier for a given span, what trace it belongs to, and then some flags about sampling. Every span has a name. The name is often descriptive, but it also can be tied back to semantic conventions. There are a few different types of spans. The ones that are most common are server and client. Optionally, a parent ID, or often there's a parent ID unless you're the root span. And then status of OK or error, key value attributes. These attributes, again, that we talked about. So you could have resource attributes, you could have instrumentation stuff, but you could also have a ton of other metadata. Okay. So you might be thinking, yeah,
Sorry.
please.
Are the spans similar to like slices from Perfetto?
Yes, I believe that would be very similar. Perfetto is kind of like in process though, right? That's an Android tool?
Android and Linux, yeah.
Okay. Yeah, so that's usually within a single process. So it would be very analogous to like a portion of a call.
You can also do, F traces and stuff as well.
Okay. Yeah, I think it's very analogous, yeah. Okay, so you can imagine in this world where you have a bunch of services talking amongst each other and they're trying to share this context, well, how would a span ever know what its parent span is or what trace it might belong to? And that there's something called propagation, specifically trace propagation. There is a W3C spec. This is a link, and I'll give links to this deck and everything toward the end. But yeah, there's a W3C trace context. It basically describes how to pass context between services with HTTP headers. Oh, he's back. Oh no. He's like, well, what's them trace good for? Like, why would you want to ever use one of them trace things? And it's really good if you have a large, complicated infrastructure and you don't necessarily know what services are talking to what other services. So if you instrument them and collect that telemetry, you can sort of see, you can draw like a graph, like most tools have a way of doing that. It's good for finding bottlenecks if you're looking at a given example trace and you see one span taking a really long time. A lot of tools will color those red even if they're error state. Finding root cause is like pretty good, and drilling down and seeing details about a single span by looking at its attributes. So in a given invocation, if you have that whole trace captured, you can dive in and see every little attribute, which might include like what library you were in at the time, you know, additional metadata like who the user was. It depends on the implementation. Okay, last but not least, metrics. Probably have a sense already of what a metric might be, but in general terms, OpenTelemetry terms, it's numeric measurements that you get from instruments. They can often be aggregated and they have some sort of temporality. Usually you just have one temporality for your whole system. Like you're reporting these metrics like in deltas or cumulative, depending. It's usually one for your whole system. Okay, so there's a few different metric types. OpenTelemetry keeps it really simple. Like there's not, like some metric systems are very complicated and they have lots of different things like timer. So the first one, counter, you might have this little clicker in your pocket and you can imagine every time you click it, it goes up. And that's all it does, it never goes down. Ignore this little turny thing on the side. It only goes up. And then you might have it in your pocket, you click it a few times and you look at it and you see a number, and that number is guaranteed to be larger than the last time you looked at it. There's also something called an up-down counter. And apparently you can buy these like on Amazon. I didn't know they existed. That's kind of cute. I don't know why the green is down and pink is up. Like green seems like the default would be to count up, and like pink is like, oh, I made a mistake. Like go backward a little bit.
Maybe it's golf.
Yeah. Oh, golf. Mm-hmm. Lower is better.
You can, yeah.
61.
I love it. Gauge, you know, it's just a number. That number can vary. It can go up or down, but it's not necessarily a counter. It could be like a floating point value. And last but not least, histogram, which just like the other ones, it kind of counts, but it's counting in these little sliced buckets, these little quantiles, and you can report it like this, and you can see how many of a certain thing happened. And this is really good when you don't want to just average, right? If you're taking if you have lots of measurements in a small time, you don't necessarily want to like only report min-max average. You sometimes want more granularity, and the histogram affords you that while still being able to compute min-max average. Oh, he's back. Oh no, why use metrics? Why for using metrics? Damn, redneck zombie. So you can make pretty dashboards, right? If you have a large series of numbers, especially if you've been gathering them for a long time, you can aggregate them and like paint some pictures. It's nice because a metric data stream will have a bunch of data points, and each data point will have a set of dimensions on it, and you can discriminate between those dimensions and do things like this, right? So these are a number of kills in horror movies, and they only ever go up, which I guess that makes sense. And so one dimension might be like who the villain was, right? So there's a bunch of data points, and it's just like counting stuff. But if you looked at an individual count that now says 13, you're over here somewhere says 13, that's this villain. And another data point comes in, it's a different villain, right? So it's nice to be able to draw these next to each other with dimensions. And metrics, because their numbers are usually pretty small, so they don't take a lot of space. Now that we're on the topic of metrics, something that people talk about, and if you run systems at scale, you've probably talked about or heard about red metrics. It's requests usually per minute or per second, the number of errors, like an error rate, and also duration or latency, like how slow your service is or how fast it is. These are the things that most people care about when they're operating like web services. And if you have tracing data and you're not sampling, well, even if you're sampling, but you can derive these red metrics from your tracing data. So as long as you know the service name, which is part of your resource, you should be able to compute these for any given endpoint. All right, we still haven't talked about Linux, right? Like this is like a Linux users group. Okay, so one of the core important concepts in OpenTelemetry is the collector. So this is a piece of software that runs on Linux and a few other operating systems, and it's considered one of the most fundamental pieces of OpenTelemetry software. And it's vendor agnostic. You can run it wherever you want, and it can collect data and send data and process data. So at a very high level, it's like gathering data from somewhere, right? It's getting telemetry data from somewhere. We'll look at a little bit more about what that might be like. And internally, it can have one or many pipelines, and then it's usually sending that data somewhere else. And look, it actually runs on Linux. Look at all these platforms we support. Oh my gosh.
I got a question.
Yes.
Is the collector running on the thing that's actually generating the data?
It does not have to. It's a common deployment model to do that, yeah. Usually, and it will run as a Kubernetes sidecar and all that stuff. So yeah, it's very common to run it right next to there to reduce latency and to get data out of process. That's the other thing. But yeah, a lot of compatibility here. We release deb and RPM packages. I don't really work on the collector much at all, but I use it every day. So pretty cool. And of course, binaries and tarbals and source code. All right, so this is unpacking that previous slide a little bit more in some more detail. And this is like where it gets kind of fun. So this collector, you through configuration can define as many pipelines as you want. Every pipeline has at least a receiver that's bringing data in and an exporter that's bringing data out. And that can just be like a no-op exporter. It could be like a print it to standard out, put it in a file, do whatever. And then processors, there are a ton of them. So in this case, we have a receiver that's, I forget the name of it, but I think I have it on another slide. It's like the log tail receiver or something. And it knows how to go scratch around in the file systems and tail logs and bring them into a pipeline. If you're running like a Java app, or you have Tomcat or some other Java microservice, you can use our agent that I help out with a little bit, and it will auto-instrument your code for you. It will do bytecode weaving, and it will have instrumentation code around all the important bits of all of your library code, and it will send OpenTelemetry protocol data into a receiver. This OTLP is kind of like the de facto like standard protocol that's expected to be used.
What's the L stand for?
So I think originally people were trying to call it the OpenTelemetry line protocol.
Oh,
It's
okay.
definitely not that. So
Okay.
it's been
It's just
repurposed
that,
into
yeah, yeah, yeah.
OpenTelemetry. That was,
A tool, yeah.
yeah.
Okay.
Mhm. It's not a proper acronym. And like if you have a Go app, there is some auto instrumentation that uses eBPF to instrument your Go binary and also give OTLP. So in this case, there's no processing, it's just receiving it and then exporting it to two different places. This is Jaeger, this is Prometheus, this is Traces, this is Metrics, if you haven't heard of those. You can also pay a lot of vendors a lot of money to take your data and do very complicated and cool stuff with it.
I was going to ask about who defines when you send the data to the collector. Is the client itself, the code itself, the SDK?
Yeah, it's a feature of the SDK. And so an instrumented application will have an instance of one of these language SDKs. And that SDK usually has a batching exporter, and that batching exporter typically will do one of two things. It either waits for a buffer to get full and then it exports, or it times out. So it's like whichever comes first. And that's usually how the exporters here work. The most minimal configuration will just export it as soon as it gets it. It's like pretty inefficient to do that on the wire, but you could do it that way. Right, so all of this is configured with YAML, because that's all we do anymore is just write a bunch of YAML all the time. But for example, this just shows this does not necessarily map into that other diagram I just showed, but this is an example of defining receivers, and here's an OTLP receiver that can take stuff in over gRPC or HTTP. And also this file log was the name I couldn't remember before. That's telling you where to go look for stuff, what types of files to look at. And then it's also parsing it, because these are JSON files. It's parsing it and pulling this time field out and putting that into an attribute, which can then be processed farther down the pipeline. Defining some exporters, defining the whole service is what ties it all together, where you have receivers, processors, exporters, and you can do that for all three of your signal types. There's some other extensions that you can run in the collector. Like if you want to use zpages or have pprof, you can do that as well. Health check endpoint. What I wanted to do actually here is to go to I cannot see this at all. And use the wrong glasses. I think that's something. This might be really challenging, actually. Okay, so just to I think this is really impressive. So I want to go to the collector contrib.
Can you make that a little bigger?
Yeah, that's a really good idea. Oh yeah, okay. A little easier. Okay. So there's a bunch of different contribs, but I want to find the collector contrib, just to give people a sense of what's out there for the collector. And this is in addition to all of the stuff that's in the core distribution, which has OTLP and all that stuff. So if you just look quickly at there's exporter and receiver and processors. Let's just look at receiver. So this is ways of getting data into the collector. So this is in addition to the industry standard OTLP now. There's all of this stuff. If you're running Active Directory, you can there's a receiver to scrape data or pull data or receive data from Active Directory. If you want to get stuff from S3, if you want to get stuff from Carbon, whatever that is, right? There's just so many different options of getting data in here, and it's just growing with every passing month, and it's really pretty impressive. If you run Kafka, you can get data off of Kafka queues. If you want to just get stuff from a named pipe or go scrape it out of MySQL, there's I wanted to show this because I think it's important to understand just how rich the ecosystem is and the number of data sources that are becoming industry standard.
So this is like a recipe, plug and play for MySQL or Mongo or whatever.
Yeah, let's dig into one of those because MySQL is what I was hovering on. If you just scroll here, every one of those in that list has this block, and so it gives it a stability level. This is under active development, kind of beta for metrics, and it looks like it does not do tracing. But it describes what it does, right? It's it queries these global status tables.
Oh, okay.
And it does this. And here's how you can configure it. Here's all the things you can specify in the YAML. And typically they give an example, right? So
Nice.
You could put that in your config. And I think the collector contrib distributions contain everything. Like, they're pretty big. So I think they do contain everything, but don't hold me to that. I could be wrong. I haven't found something that wasn't in there yet. But I also don't work on that project. Anyway, I really love that. And you can do the same exercise there for exporters. So same thing, if you want to send your data to one of, couple dozen vendors, you can do that. But if you just want to put it in Kafka or put it in a file or do whatever else, here's all of the different things you can do with it. Okay, fun. So I hear you like code. If you are a software engineer, if you write code, here's the incomplete list of the current languages and their stability levels for the 3 signals. So if you're a C coder, we have a stable API and SDK for traces, metrics, and logs. And that's true of most things. Rust is pretty young, and there's not a ton of people working on it right now, so help wanted. But it's in beta for all the 3 signals. Ruby got to stable pretty quickly on traces, is still working on metrics and logs. I also work on Android. That's not shown yet in the stable. And Android is in development. Okay, so I jumped ahead. So this is what we just did. And then, more Linux stuff. So I touched on eBPF a little bit for Go. I think that's still considered beta, but there's a lot of auto instrumentation now for popular Go libraries. So if you have Go code that compiles to a binary against some known libraries, they have eBPF packages or instrumentation code that knows how to grok the stacks that appear from that and turn them into tracing data. There is some new profiling instrumentation that's very fledgling, but also leverages eBPF. And then there's this thing we're working on right now called the OTel injector that uses this this LD preload mechanism for getting code into a runtime without users having to do anything to manually instrument or put anything into their runtimes. Because there are like a lot of big companies that cannot or are unable to change how they deploy code, but for some reason they can change LD preload. I know that you're thinking the right thoughts. All right, I think we have to talk about semantic conventions because this is a hugely important aspect of OpenTelemetry, right? If I call this a tomato and you call this a potato, we're gonna have a bad time, right? Like we're not speaking the same language. Part of the semantic conventions or semconv is to make sure that we're talking about the same stuff and then also what that stuff means, right? So this guy's like, I was looking everywhere for this like CPU metric that you told me about and I couldn't find it, it's hiding somewhere. And this person's just like, that's because you spelled it wrong.
I've experienced this a lot.
Yeah, right. So the goal of the semantic conventions in OpenTelemetry is to have these names and what they mean written down in a standardized way, in both a machine readable way and a human readable way. So this is kind of what it's attempting to answer, right? Like, what do we agree on calling the thing? What properties does it necessarily have to have? What other properties might it have? What are the types and units where it's relevant? And then I said thank you because that's the end of my deck. I will show you I think we should also just bump over to the semantic conventions. Just to show you some of this. Actually,
Just for, I've heard that called controlled vocabularies in other contexts.
okay. I like that. Right, so this, the website is, I will say there's a lot of information on this website. I'm often impressed at how much work has gone into this and that's maintained and kept up to date. If you're curious about these, you can come in and let's say that CPU example that we were just talking about, that's a metric, right? So I went to metrics, and it's not really a part of HTTP, it's part of system, right? System CPU probably. And then, let's see. So the metrics are down, that's memory metrics, processor metrics. Here's the utilization, right? So it's like this. So if you dive in, you can see the type of instrument that generates this. The unit is 1, right? Because it's not like feet or seconds or anything. It's a percentage. And then you get a description that talks about what it means, right? So you see a value, if this comes across in your data stream, you can read this and then understand pretty quickly, like it's for each CPU, it's calculating the change in cumulative CPU time over a measurement interval divided by the elapsed time, right? And so for every one of these categories, you know, you can, for each one of the signals, for each one of these categories, you can dive in and see exactly these names that have been agreed upon and also their stability levels, right? So, and now I click on HTTP knowing that it's stable. So across all of OpenTelemetry, whether it be the language instrumentation implementations, the APIs, the SDKs, all of that will agree whenever they're touching HTTP server request duration to call it by the same name everywhere. And we're seeing this be adopted outside of OpenTelemetry, right? These constants are defined. You can obtain generated code and constants that contain these values so that we can all stop calling these by different names. And there's a lot of bike shedding you can imagine that happens. And sometimes it's fun, sometimes it's not. But anyway, that's what I have.
Hang on.
Yeah.
So let's say
Go
you just invented a thing and you need a name for it.
Yeah.
How the hell do you figure out whether it already exists or not?
Well, you search for it.
Yeah.
Yeah.
But how do you? What do you search? You just invented your own name. So how
Yeah.
do you search for the thing that's
Well,
not?
if it's your own name, you
Yeah.
would search for that exact name, and
Yeah.
there'll be no matches, and you know it's not there. But
Yeah.
if there's something that,
Really, it ought to be.
yeah,
Yeah.
I think you would maybe try like just
You
looking
look
for
around
do a little
harder.
diligence
Yeah,
in
yeah,
looking,
yeah.
or like try and find out if it makes sense that it's in one of these if it's obviously one of these categories,
Yes.
right? And then look in there first. And then, you know, you could open an issue,
Yeah.
and somebody will tell you pretty quickly
Right,
if it
like-
exists. Yeah.
Dumbass, it's already there.
Yeah, totally.
Yeah.
Except they're usually pretty nice.
Yeah.
Okay, I think I went slightly longer than what I promised, but let's get back over. I did hit the end of the slides, and I like this bird a lot. So I'll leave this QR code if you know, for the recording or for anybody that wants to scan it. This is a link to this deck, and then I have just a few resources like to the repo and to the website and to the OTel dev stats. So
Nice.
yeah, thanks.
Thank you.
Questions, please. Yeah, let's open it up.
Consumers that the collector seems to opt in.
Can you say that one more time?
What are some of the common consumers of the data that from like the collectors would send off?
Yeah, so if you are like in a startup, or if you are tinkering, or you work for a nonprofit, you know, you might spin up your own instance of Prometheus, and you might spin up your own instance of Jaeger, or you might send it to OpenSearch. Like that's also a very common one. Yeah. So sending logs to OpenSearch is a super common use case, but also
Not very hard.
What's that?
It's also not very hard.
Yeah, yeah. But if you wanted to, you know, do some aggregation and maybe glean some metrics from those logs before they hit OpenSearch, like you could do some of that here. If you wanted to pre-filter before it ever hit OpenSearch, you could do some of that here. But I think that those are kind of the main use cases. But let's be real, there's corporate money behind this, and a lot of people are sending this to companies, you know, like the one I work for, but also all of our competitors.
Yeah.
Yeah. And what they can offer in terms of like value-added experience is just unmatched with anything in open source yet. Like, and OpenTelemetry, I forgot to mention this, but it's very purposefully not a UI. Like they're not trying to build a backend or a data store or a user experience at all. We're on the data collection and processing side, but not the storage and rendering. Yeah.
How does OpenTelemetry deal with like collector replications if you put this in a cluster? Does it gracefully deal with losing one without losing data that's in process, or what happens there?
So you're talking about clustering collectors. So typically the collectors run kind of matched one-to-one with software. They're considered pretty lightweight and they're pretty efficient. So you would just have one next to your software, next to your application, but you could cluster them. I know that there are people that do deploy it that way, where you could have a load balancer.
Yep.
And then have a bunch of collectors behind it. I think there are some processors that are stateful, And so you have to be really careful about that. I mean, the goal is to never be stateful in there, but I mean, there are some that are, and so you'd have to be careful in that case.
I don't know if there is any discussion regarding privacy. Not just, I mean, by the way, I don't know, the user submitted this password or something like that, but also in terms of what type of behavior you can detect or derive based on a series of traces, for example. Like, this guy always searches X, Y, and Z, but these other type of users do something else.
Right.
And
Yeah,
if
so
there's any issue about that.
there certainly is, and there's some guidance, mostly in the semantic conventions about not propagating PII for one, but other sensitive data. But I think, you know, like a server span will identify. I think it can identify like the client IP address, just as one example. So if you hit a server, when it sends its span, it should have the client IP on it. I'm not sure if that's on by default, but the semantic conventions will say and have some guidance around that. The other one that's like very obvious is like people still put secrets, or like not secrets, but like sensitive stuff in URL paths is the main thing. Like, and that's definitely recommended to not be included. An implementation could do that, but I think it would be scrutinized, and I think it would be frowned upon. There's also, as far as URL paths, you know, if you're putting someone's social, or if you're putting some other unique user identifier in a URL path, you're also creating like routes that are high cardinality, that are hard to metricize. Right. So like it's hard to do aggregation over them when there are so many dimensions.
It sounds like this software is designed for large numbers of systems in a large compute environment. Is there a way, does this make any sense to try and think about applying it to small devices, like little routers, little networky things spread around?
Yeah, it's an interesting idea. I don't know of a lot of art around that. It's interesting. I know that there, something I've been wanting to explore is like maybe doing like an MQTT mapping. Mm-hmm. I don't think anybody's done that yet. It definitely is right now geared more at kind of the enterprise and like Kubernetes
stuff running in a data center.
Yeah. Yeah, but I think there's room for it. I think, you know, it probably would require an alternate collector. Like the collector is lightweight, but like what that means is like you're probably not going to run it on an ESP32 or something. You're probably not going to run it. You definitely can run it on a Raspberry Pi, but like you're probably not going to run it on an Arduino.
Do you run this at home?
No, not in my personal life. And this stuff is interesting. I'm stoked to be like getting paid to work on open source. It's really fun. But after I punch out, I'm interested in other stuff. Yeah. Cool. Another question?
More thoughts than a question.
Yeah.
I just my computer. I come from this from almost strictly the trace side, because I work on hardware. So yeah, it's interesting. I was looking through some of the specification for the system traces, and it's interesting. It's not quite as deep as we usually go.
Mm-hmm. Yeah, when I talked about the signals, there is another signal that's the profiling signal, and that might be more analogous to what you're describing. There are no implementations that are stable yet. It's still pretty new, and the way that the community developed it was they kind of fleshed out the protobufs first. Like, how can we represent a sequence of call stacks like on the wire, and then it's up to implementations to sort of figure out how to fill back into that. And those don't quite exist in the community yet. There are some bespoke implementations, but it's trending together. Like, it's getting better. So yeah, profiling as a signal is probably closer to the thing you're describing. And we had a user that opened an issue on Android asking for the whatever the tracing feature that you mentioned earlier was.
Perfetto.
Profetto. They were like, yeah, we want to tie into Profetto on Android. We were like, that's a lot of data.
Actually, as far as those kind of collections go, it's actually pretty lightweight.
Really? Okay.
You go into the other ones, they get massive very quick.
Okay. Cool.
Sounds cool.
Yeah. So let's.
So I'm
you wanna
still
call-
grepping logs, actually.
Yeah.
So
You're not alone. I mean,
we have a wiki, Personal Telco has a wiki, and it's getting super hammered by LLM bots right now.
shocking.
Yes.
Yeah, isn't it? And so like I spend evenings just grepping like, oh, who's still hitting me? Who's still hitting me? Which net block is he in?
Mm-hmm.
And yeah, so I'm thinking, could this help me at all? And I'm not sure it could. I mean, we got one machine that's
Right.
really,
Yeah.
so we don't need it to scale, really.
Right.
Just need them to go away.
Yeah, exactly.
Yeah, I mean, you could stand up a collector and like bring the logs in and like
Yeah.
pull out like IPs and whatever else, like routes maybe, and then do something with that. Like you could. There's probably an exporter that does some kind of alerting.
Right.
At that point, though, with just one system, you might be better off doing just Prometheus on its own and manually setting up logs into that.
Yeah.
That'd give you like most highest use IPs and all that.
The interesting thing, not to hijack this at all, they're coming from NetBlocks. There's one request per IP. I mean, you know, so they've worked around the
Oh,
whole,
yeah.
you know, rate limiting thing.
Mm-hmm.
They're ignoring the
Robots?
the
Oh my God,
robots.
yes.
Yeah.
Do you have what's the name? This Egyptian.
Oh, the Anubis.
Anubis.
Yeah, we've been looking at that, and somebody else suggested a different.
Nephrites?
No, I don't remember what it was. I've got it written down somewhere.
So, kind of I think I probably, I might already know the answer, but just out of curiosity, in terms of a use case, a small use case, because you mentioned it's like for big stuff, but if it's scalable, I would imagine a small environment would still work, right, or still be useful. So I'm kind of curious, would this kind of thing make sense for monitoring on a small scale? So one of the challenges I'm having right now is I'm having to, on one of the projects I'm working on, just a small thing, I'm splitting my project up into pieces. There's a database, and there's a front end and a back end. So the back end application reads from the database with Postgres, returns JSON documents, and then there's a front end that creates the web pages from that, right? So like, break it apart. And the reason I'm breaking it apart is because the language I'm using has a tool chain that kind of changes over time. So I'm using an older distro that hasn't really changed since 2022, but there's a newer version, so I'm containerizing it out. So I've got this one box, and now it's going to have maybe 2 or 3 containers, but there's still that Apache's going to reference the different IPs, so it's very small. But I'm starting to get to the point now where like, okay, how do I keep track of the logs for all this? So would it make sense for the collector to be running on each container and then also the host, and then have that all feed through to something that I can view and see, okay, when a page didn't load, I can see would I be able to see which component failed? Is that kind of the use case, or am I not fully?
No, I think that's definitely workable. I mean, you could have one collector deployed per container, and it could be augmenting your logs with additional metadata about that container. Like you could be putting any other like metadata from that container could be appended onto those log records if it's not already there, and then you could be using that as a factor. Like for like, so if, just to wave at this drawing a little bit, like if this was container 1, this was container 2, and they were different versions, and you had them going through a pipeline, your processors in here could be labeling that one version 1 and version 2 if the logs don't already contain that, and then you could be sending those logs to either to another file or to OpenSearch or whatever that you're currently doing with it.
I'm currently repping it.
Yeah.
Trying to SSH into each of them and figure out which one's doing what. So
Yeah.
My understanding was assumed that it's just a matter of, for the size of your project, is it worth the setup?
Totally. No, it's a good question to be asking.
yeah,
Like,
and that's
Yeah.
that's
Because
what
like
I'm-
you can make this work on a single system. Is it worth the setup?
Yeah, no, it's a good question. Yeah, for sure. And there's a learning curve, right? Like, just even clicking around the website and the number of components that are available, like it's big. Like as a topical area, it's huge, but
Yeah, like a year ago, I worked on a project where we were building out automated testing, and we manually had to make a bunch of Python scripts that would take the output and push it into open source. So it's kind of, we had to make what this does ourselves essentially. It was a small scale project, it worked out, but we had to like figure out what was our naming convention. We also had to come up with a naming convention. If you're using this, enforce a naming convention on you, which might remove that burden and have to figure that out for yourself.
Yeah, that's where I'm struggling, because the project is small in terms of like who it's serving basically, but then I got to the point where the size of the data that I'm actually pulling in and displaying for my little data dashboard is huge. So now I actually need to care how fast that Postgres query takes to run, you know, that kind of thing. And so it's a small project, but I'm sitting on 28 million records. So, you know, I kind of want to know if it's slow. I want to know, well, which component was slow when I clicked that link, because it could be me generating the HTML, or it could be just Postgres being slow for that one query.
Yeah, so in my experience, tracing is really good for that use case, because what you'll end up seeing is like you have an n+1 query somewhere, and that will show up like pretty quickly. But
By the way, is there any telemetry on the collector itself?
there is, yeah. I don't know the details about it, but it does have internal telemetry that it emits. It's like, I don't know, like counts and buffer sizes kind of stuff, but I don't know the details. I think it's fairly minimal.
Right.
And I think it's turned off by default, I think.
Makes sense.
Well, I guess one more question. Is the processor a separate process? They're looking at the list of collectors you pulled up, and one of them just said named pipe collector, which I'm assuming you can just pipe something into it. And then I'm wondering, well, then how does it get processed? Is there...
The processors are not, I don't think they're separate processes.
Because I would assume if you're sending stuff in through a pipe or something, you'd want to filter it or format it or something, because you don't necessarily have control over what's coming in.
Yeah, so let's look at what's in contrib. So there is something I didn't even want to talk about at all because it's complicated, then it would take a whole session, but there's a thing called OTTL, the OpenTelemetry language, and it is a language for doing data manipulation inside of a processor.
Why does
Or did I just open a can of
Everyone has to create their own language, yeah, I know.
I think OpenTelemetry has 4 or 5.
Yeah.
It's ridiculous.
We can close the can of worms then.
So like, you know, here's one that'll do filtering, like if you want to throw some data out.
Well, there's a different processor folder.
Oh yeah, so there's, yeah, so just like there's the receivers and the exporters, there's all these different processors, and so I don't know.
Oh, and they're named kind of reasonably, so you can kind of tell it just by looking at it.
Yeah.
What it does, like GeoIP or whatever.
Exactly.
Log transform.
Redaction, like if you need to filter, like, you know, redact some PII or other data, you can use that one.
Would you do like multiple of these? Like if you have one source, so you could process it multiple, so you have one processor for redacting something and then another one that then converts or whatever.
Totally.
Okay. That makes sense.
Yep, they can be chained.
You had a slide about deaths in the movies.
Oh yeah.
So you said they were monotonic.
Yeah, because
Have you seen Reanimator?
I know, no one can. They don't include the people that come back, I guess. Like, if they come back, it's still counted as a kill.
Yeah, okay, sure.
Yeah. I've seen Reanimator a few times, Russell.
We need to scale it for the number of bad guys in the movie.
I was just thinking about the assumptions.
Since we're segueing movies, what happened to the psychotronic section at Movie Madness? The label, the
Did it disappear?
Yeah.
Maybe they'll bring it, you know, they're moving it, right? Maybe they'll bring
Oh,
it.
they're moving Movie Madness?
So-
Yeah, it's going to be in the Hollywood district, like across from the theater.
It turns out that a former Plug member bought the building that they're going to move into.
Cool. It's where that Magnolia wine bar was.
It was right on the corner across the street, yeah.
Yeah.
Wow. Former
So it's-
Plumb member. I didn't know you were allowed to leave.
Well, they haven't come in like 20 years or something. He should be a speaker.
It does seem like that's a film term that's kind of fallen out of fashion. Like people don't really use it anymore. Let's say like Grindhouse or Cult or whatever.
Well,
yeah.
I always thought it was a cool name.
Yeah.
I mean, it is a very cool name. I haven't heard it before.
Yeah.
I just remember
Should
they had
be
a
in there.
psychotronic section, and I was looking for it recently and couldn't find
And
it.
it was gone, huh? That's where you gotta get all the good movies.
Yeah, it's all the way in the back corner.
But not the back room. That's it.
Have you seen Squirm? I think it was
Squirm.
called Squirm,
Yeah.
yeah.
Classic.
Yeah.